construction industry is involved in construction and civil engineering programs, as well as the maintenance and reconstruction of existing structures. The construction industry is one of the industries that play an important role in the growth and enhancement of the economic sector and in the growth of one's country as well. While the construction industry contributes to the development, this is not an environmentally friendly activity at the same time. So, if the advancement and development of this industry is not well planned, there will be a lot of problems. Construction industry is one of the world's booming industries. This industry is primarily in the urban-based one that concerns both the planning and construction of real estate properties. The repair or modification of any existing building is also part of the construction industry. This industry can be categorized into three basic categories, namely, first, construction involving heavy and civil engineering. It is the construction of large projects such as bridge, road, and etc. Second, general construction. Building works involving the construction of real estate such as residential or commercial real estate assets. Third, construction projects involving specialty trades. Construction works that involve building up of specialized items, namely electrical related works, work on woods, and etc. Construction industry is a booming industry and continues to do so, especially in developing countries, with the continuation of the development process. With the development process, the migration of people from rural to urban areas takes place. This phenomenon is most significantly observed in the Asian tiger nations such as China and India. Therefore, in such countries, the construction industry is also growing.
Construction and Engineering Management, or CEM, is a combined study of basic civil engineering and construction management courses. Students in this program have the opportunity to develop additional expertise in mechanical engineering, environmental engineering, management, building, information modeling, and many other options through minors in these fields. Graduates shall be knowledgeable on the fundamentals of structural and construction engineering like design and analysis, material testing and quality assurance, building systems, construction technologies, and surveying. In construction engineering management, it involves application of technical and scientific knowledge in construction projects. While engineering focuses on design, the construction management is concerned with overseeing the actual construction. CEM often represents a blend of both discipline, bridging design management, or project execution. Construction engineering managers may have an educational background at both undergraduate and graduate levels, as well as experience in construction management techniques. Their skills may be applied widely to the architecture, engineering, and construction industry.
The history of construction engineering and management education program closely follows the emergence of construction industry as an economic force. The program began during 1900s in some universities, and majority of them also offer civil engineering courses, since we all know civil engineering and construction engineering are similar to the degree that both deals with the construction industry. The difference was just civil engineering focuses more on the design, planning, and analysis of the construction, while construction engineering is primarily on site management of an actual construction. So what is the objective of this program? The objective of Civil Engineering Management or CEM program focuses more on academic discipline and skills. So how? The program prepares the students with the tools they need to become construction engineers and managers by letting them apply and discover concepts, emphasize practical applications, as well as basic principles to maintain and create educational environment that will enable the graduates or even undergraduates that will take the bachelor's degree to practice of becoming a successful construction engineers and managers for the advancement of society and to promote professionalism.
Construction engineers are key players in the successful completion of a construction project. They have the option of either working in an office setting or out in the field. Here are some of the career paths to choose from with a degree in construction engineering and management. Number 1. General contractors. They are responsible for overseeing construction projects and entering into the prime contract with the property owner. Number 2. Owner and developers. Developers are responsible for organizing contractors and subcontractors, while owners are the ones who will maintain the overall responsibility for the profitability of the project. Number 3. Mechanical and electrical contractors. Mechanical contractors are responsible for the heating or cooling systems, refrigeration, piping, and plumbing of a building, while electrical contractors, on the other hand, are responsible for making sure those systems work effectively, safely, and most of the time, environmentally friendly way. Number 4. Construction engineering managers can also work in the field of renewable energies. They are carrying out site inspections and energy surveys, feasibility studies and cost estimates, and checking site and ground conditions for the installation of renewable technologies such as the wind turbines. Number 5. Consulting and design firms. They are responsible for the consultation, investigation, feasibility reports, engineering design, procurement, and construction supervision. They can also work in the fields of oil and gas industry, aviation industry, law firms, and historical restoration. The job responsibilities of a construction engineering manager includes number 1, planning and overseeing the construction operations of a project, which includes conducting site layout, scheduling, selecting equipment, organizing work crew, managing materials, safeguarding the environment, building temporary structures. Number 2, designing both temporary and permanent structures. Number 3, checking and modifying plans and specifications for constructability, efficiency, and safety. Number 4, developing cost estimates and preparing bids. Number 5, utilizing building information modeling (BIM) software for 3D models. Number 6, managing subcontractors. Number 7, working with the owner to ensure the project meets requirements. Number 8, solving site problems, moving between fields and office. And number 9, gaining additional education training.
Here are the types of modern methods of construction. Number 1. Precast flat panel system. Precast flat panel system. This method of construction involves the procedure of making floor and wall units off-site. For this, separate factory outlets and facilities is required. Once the panel units are made as per the design specification and requirements, they are brought to the site and placed. This method is best suited for repetitive construction project activities. Number 2. 3D volumetric modules. 3D volumetric construction. As the name implies, the 3D volumetric construction involves the manufacture of 3D units in the form of modules off-site. At the time of installation, they are brought to the site and assembled module by module. Each modular unit manufactured are 3D units. Hence, this construction is called as 3D volumetric construction or modular construction. Number 3 is called flat slab construction. Flat slab construction. The flat slabs are structural elements that are highly versatile in nature. This versatility is used widely in construction. The flat slab provides minimum depth and faster construction. The system also provides column grids that are flexible. The flat slab construction also means of increasing the energy efficiency, as this allows the exploitation of building thermal mass in the design of ventilation, heating, and the cooling requirements. Number 4. Precast cladding panels. Precast cladding panels. The cladding system is the installation of a material over another that finally acts as a skin or a layer. This system of layer is not only intended for aesthetics, but it helps in controlling the infiltration of the weather elements. Number 5. Concrete wall and floors. Concrete walls and floors. Concrete walls are mainly applied for seat walls, retaining wall, decorative exterior, and interior finishes. The concrete is also used as a flooring material. As per the latest technology, the concrete floors can be provided with good finish to provide smooth and attractive flooring. Number 6. Twin wall technology. Twin wall technology. The twin wall technology is a high resolution of wall system that combines the qualities of erection speed and precast concrete with the structural integrity of in situ concrete. This type of wall system guarantees a structural integrity and waterproof of reliability for the structure. This system of construction is faster than normal construction methods and economical. The twin wall system is mainly employed in association with the construction of precast floors. Number 7. Precast concrete foundation. Precast concrete foundations. For the rapid construction of foundation, the precast concrete system can be employed. This method is more suited for a bespoke design. The foundation assembled is mainly supported by concrete piles. During assembling, both the systems are connected together. This is the best suited for extreme and adverse weather conditions. When the construction is dealt on a highly contaminated ground, this system of construction is a best choice. And the last is called concrete formwork insulation. Insulating concrete formwork. The system of insulating concrete formwork have thin-walled panels that are either polystyrene panels or blocks are employed. These are built quickly to create the formwork as the wall of the buildings. Higher level of thermal insulation is provided by expanded polystyrene blocks. The concrete core will provide good robustness and better sound isolation.
So let us now head on to another topic of construction engineering and management, which is the role of design in construction engineering. So basically this topic talks about the importance of design in construction engineering. Before we head on the topic, let us first discuss what is the meaning of design. Design is a plan or drawing produced to show the look and function or workings of a building, garment, or other object before it is built or made. It is an arrangement of lines or shapes created to form a pattern or decoration. It decides upon the look and functioning whether it is in a building, garment, or other object by making a detailed drawing of it. In terms of construction, design is the process of creating a solution to a project brief and then preparing instructions allowing that solution to be constructed. So now that we know what design is, let us head on to the main topic. So design is of paramount importance in the construction engineering since the usefulness of the building, safety, cost, and environmental factors are all influenced by the design of the building. Therefore, the design aspects should be thoroughly considered before the construction starts, since after the commencement of construction, any changes required in the building may either be extremely expensive or even may not be possible. The design consists of drawings with the specifications prepared by a team of designers, normally including the surveyor, architect, construction engineers, and structural engineers. The team of designers may also include other specialists of the engineering profession, depending upon the utility and size of the building. Fundamental elements of the design process include establishment of objectives and criteria, synthesis, analysis, construction, testing, and evaluation. That's all for the topic of the role of design in construction engineering. Thank you.
Construction projects. Construction, a process which consists of assembling or building infrastructure. includes all work and materials required for construction or finished structures. These also include site foundations, preparation, electrical work, mechanical work, and any work required to complete projects. Types of construction projects. Number 1. Residential. These projects include townhouses, houses, condominiums, apartment, cottages, subdivisions, and single-unit dwellings. The designs are usually made by engineers and architects, and construction executed by builders. Number 2. Building. Constructing building is the most common type of project. It's a process of adding structures to properties. Most projects are small renovation or room addition. Most new building projects involve construction of sheltered enclosures with access for housing people, machinery, equipment, and supplies. It also includes installation of equipment and utilities. Number 3. Commercial and institutional. These buildings include a whole lot of project sizes and types, like hospitals, clinics, schools, universities, stadiums, sport facilities, shopping centers, retail stores, warehouses, manufacturing plants, etc. Special engineers and architects are usually hired for the construction of these buildings. There are very few competitors in this market segment since it costs a lot of money and requires greater sophistication in terms of commercial and institutional buildings when compared with residential projects. Number 4. Industrial. This is just a small part of construction industry but a very important part. Projects are usually owned by large industrial corporations like medicine, power generation, manufacturing petroleum, etc. Number 5. Highways. These involve alteration, repair, and construction of roads, streets, alleys, highways, runways, paths, etc. It also includes incidental construction.